Hey there. We're going to talk about parallelograms and triangles today, areas of those two particular polygons. So here's a parallelogram, right? And remember, definition of parallelogram, you have one, two pairs of opposite parallel sides. And remember also the opposite sides are also congruent by property. But in any event, what we can do here is we can drag this little demonstration about and show that the area of a parallelogram is really, when I cut that in half, I move this triangle here, what you end up with is essentially the same as a rectangle. And so I'll play this right here, and we're going to turn that into a rectangle. And no, these two are the same, right? This triangle here and this triangle here. So if we kind of ignore this light blue area, the same dark blue area is the area of the rectangle, which would be base times height. Okay, so we can move that back over there. We can drag this around and see what kind of fun stuff happens. But we start over, that triangle moves back over there, and oops, let's put this right where it belongs. And I can mess around with this special type of parallelogram actually, where we can cut it into two congruent triangles. Not the only type of parallelogram, but nonetheless, this shows that the area of a triangle parallelogram is really the same as the area of a rectangle, that being base times height. Okay. We're also going to talk about triangles today, so here is a nice triangle applet. Again, thanks to the folks at NCTM for making this nice applet. Here is a math open reference applet, and we're talking about triangles. So a triangle is, imagine this extended parallelogram here. Okay, so if I extend this triangle to make a parallelogram, what you get is the area of that triangle, the yellow triangle, is half the area of this parallelogram. And of course the area of the parallelogram is base times height. So that's where area of a triangle, 1/2 base times height, comes from. It's half of the area of a parallelogram. So one thing that this applet does a nice job of showing, it actually computes values, but it shows you what it really means to be the height or the altitude of a triangle. And we can drag this about here till we get there. And now we have what's called an external altitude. Okay, it's still the height given this base. Okay, and the base and the height will always be perpendicular for triangles or for parallelograms. We can kind of drag this about here. We've got an obtuse angle and obtuse triangle, and therefore we have an external altitude here. But the base still is 6, and the height of the altitude is 7.6. Okay, so we take half of 6 times 7.6. But I wanted to show you this applet, thanks to the folks at Math Open Reference. Ching ching. Just to show you what triangles could look like, okay, and where those altitudes could lie. They could be internal altitudes or heights relative to the base, right? So the base and the height are perpendicular. Or if we have a right triangle, the altitude x ends up being one of the sides, one of the legs of that right triangle. Okay, base, height. Or sometimes you have kind of this messy case where you have an external altitude given this base, 4.9. Okay, so to summarize, here's what we're looking at for a parallelogram. Remember, those guys look like, maybe not, here we go. Here's our parallelogram. And remember, by definition, you got parallels and parallels. You also got congruence and congruence by property. But the area of this guy is 1/2 base times height. And the base is this blue piece. The base could be either, really. But the height is all relative to the base. So if this is my base, then the height is the perpendicular, the altitude. Okay? And the base and the height will always be perpendicular. So here's our base, B, and our height, H. And actually that's wrong. The area of a parallelogram is base times height, not 1/2 base times height. A triangle is base times height times 1/2. So again, you can pick any of the 3 sides and pretend that's our base. And our height is going to be the altitude, perpendicular to that particular base. And the area is going to be 1/2 base times height for this triangle. Okay, so parallelogram, base times height, triangle 1/2 base times height, because as I showed you a little bit earlier, that triangle is half of that parallelogram, therefore half the area of base times height of that would be parallelogram. And I also showed you how we can take this parallelogram piece of that and bonk it over here, and that's why the area of a parallelogram is the same as a rectangle, base times height. Okay, so let's use this. Here are a couple examples, and I'm sure those formulas aren't new to you. You guys are wicked smart. So let's look at this particular example. Let's say we got this little action parallelogram, and let's make those 45s. Don't really look like it. Let's pretend they are in 20s and 6s. So we're looking for area. All right, now the base times height is, of course, the area of a parallelogram, but remember this is 20 and that's 20, those are both 6. So how are we going to get the height, right? We have either of these, we can use the base. Let's use 20 as the base. All right, so the area is going to be 20, which is the base, times the height. So I need to find my height, so I'm going to drop that altitude. And this is kind of a bad diagram, but that's a 45-degree angle too, all right, by T180. So we got 45, 45, 90, and these need to be congruent, even though they don't look like they're congruent. But those are both my two x sides, right? 6 is my x root 2 side. And so solving for x, if x root 2 is 6, then x is really 6 over root 2, but that's kind of a messy way of saying 6 root 2 over 2, which is 3 root 2. All right, so that's this piece here, and that's this piece here. Now, I don't really care about that piece there, because I already have 20 as my base. What I do care about is the height, the altitude, relative to that 20 base. So the altitude, the height is 3 root 2. Bonk. I got that using 45, 45, 90 ratios. So now I can multiply base times height to give me my area. So it's 60 root 2, and that's going to be in square units. All right, how about this problem? What if we had this particular triangle, and let's make it a right triangle, but let's go there. Let's do that. Okay, so the question is, what's the area of this guy? Well, remember, it's half the area of a, it would be, in this case, special kind of parallelogram, rectangle, but we don't really need that. What we do need, comma, however, comma, is to know what the heck the base is, right? Here's our height. We already got the height, right? Relative to this particular base. Remember, the base and height are perpendicular. Since it's a right triangle, right, we can use 5 as either the base or the height. So I'm going to call that my base. Therefore, the height is 5, right? And so my height here, there's my height, 5. Great. Perpendicular to this base. So all I need to do is find out what b is. I'm going to do that using P. Diddy, Pythagorean theorem. 5 squared plus b squared is 13 squared. You may remember that's a 5, 12, 13 right triangle. It's pretty special. So therefore, 12 is my base. Perpendicular to that is my height, 5. It's a right triangle. The altitude is one of the legs. Makes it nice. So the area is 1/2 times what I found my base was 12 times the height, 5. Now I'm going to take half of 12, which is 6. Don't distribute. There's no addition or subtraction. Multiply 12 times 1/2 to get 6 times 5, which gives me 30 squared units. Okay. So that said, here are 2 problems for you to try for tomorrow. Your turn. And we'll talk about these tomorrow in class. I want you to find the area of this equilateral triangle, and let's say we have sides of 20. As a hint, remember, those are 60-degree angles if it's equilateral. Right, drop your altitude. And I also want you to find the area of this parallelogram. And let's cut that here. And I'll give you this. This is 13, this is 5, and that's 10. Right? So for both of these problems, the issue is, well, what the heck are the area for those guys? All right? Have fun. Talk about these solutions tomorrow. Bye-bye.